let us begin with this last unit, water tank. Okay, so I will tell you some theory within 2-3 lines and some important what we can say stresses and their limits. So copy down that. This is the important thing, and these questions will be asked for the MCQ. Okay, so now water tank. Water tank. Okay, so here write down reinforced concrete tank is very useful structure which is meant for the storage of water. The storage of water. Full stop. Okay. So the stresses in the reinforcement. So this is the basic thing. What is the water tank? Okay, so for your purpose, for your design water and water tank on the ground with the flexible base, this is the most of the times 100 out of 99.9 times this is asked in the examination, because this design is what we can say not much more lengthy. Other water tanks, if you try to design, its design will be easily of 10-15 pages. Okay, so this question is most likely to be asked in the examination for designing purpose. Now we will see the important stresses. Okay, so next is the stresses in the reinforcement. Stresses in the reinforcement. Stresses in the reinforcement. Okay, so make the columns. First, write here reinforcement. Reinforcement means the area of steel or the grade of the steel. Here, reinforcement means. Okay, you can take it as a grade of steel. Reinforcement means. So here the second column is permissible. Permissible means allowable. Permissible tensile stresses. Permissible tensile stresses in the reinforcement. In the reinforcement. Okay. Again, this is divided into two columns. First is at water phase. At water phase, so phase of the water, and second thing is away from water phase. Away from water phase. So you know that at the water phase the pressure is high. So now for the different grades, I will make the columns. So this type of table it is. So now here first is Fe250. You need to remember these values, and these values can be asked for the MCQs. Fe250. What is the permissible tensile stress at face of the water? It is 115 Newton per mm square. Okay. And away from the face of the water, it is 125 Newton per mm square. Okay. For Fe415, it is 150 Newton per mm square. And this is also 150 Newton per mm square. Okay. This is 150 Newton per mm square if the thickness of the member, if the thickness of the member is less than 225 mm. Okay, and it is 190 Newton per mm square, 190 Newton per mm square when the thickness of the member is greater than 225 mm. So this is the condition given. And lastly, for Fe 500, for Fe 500, it is 205 Newton per mm square, and at this end it is 245 Newton per mm square. So this is the thickness of the member. Just now, this is the table. I hope now you have copied down this table. So now we will take one numerical for the water tank. Okay. So take this problem and take this steps as it is, and this could be the water tank, which is a circular tank on the ground, which is having flexible base. Most important problem. Take down this problem. Design a circular tank resting on firm ground to the following particulars. First, diameter of tank is given to us, and one more thing, while designing the water tank, formulas from limit state methods are not applied. Working stress method is used to design the water tank. Okay. So the diameter of tank, it is 3.5 meter. Second, depth of water is equal to 3 meter. Third, the wall and base of water tank is flexible. Fourth, specific weight of water is equal to, so the density of the water is given 9810 Newton per meter cube. Use M25 and Fe415. Use M25 grade concrete and Fe415 steel. So this is the numerical which is given. Okay, design a circular water tank resting on firm ground to the following particulars. Diameter of tank is given, depth of water is given, base of the water tank is flexible. Okay, there are two types of base, flexible base and rigid base. What is the difference between flexible base and rigid base? If the base is rigid, means it is casted along with the walls. When the base is casted along with the walls of the tank, then it will form a monolithic structure. So that is called as the rigid base. Flexible base means it is casted separately. So specific weight of water is also given. Grade of concrete is M25 normally for water tank. Higher than M20 grade concrete is used. So M25 is the grade and steel is 415. So now we will go to the solution part of this. For this now we will first calculate the thickness of the wall. Okay, what is the thickness of the wall? And for that thickness now we will calculate the hook tension. Now it is circular water tank. So hook stress will get developed over here. So hook tension we will calculate, and for that hook tension we will provide the reinforcement on the both the faces. Okay. So now we will begin with this. Write down every step. So here thickness of wall. So for the thickness of the wall, there are two criteria. Okay. To provide the thickness of the wall, there are two criteria. First is thickness is thickness is 150 mm. First criteria is provide 150 mm. Thickness of the walls means side wall of the tank. Okay. And the second thing is it is 30 mm per meter depth depth plus 50 mm. So the second criteria is 30 mm per meter depth म्हणजे एका मीटरला किती 30 mm and plus 50 mm तुम्हाला करायचं म्हणजे हे किती होणार आहे 30 mm for 1 meter. How many meter it is 3 meter. Depth of water it is given. See here depth of water 3 meter. So 30 into 3 plus 50 which is equal to it is 140 mm. Okay. So provide provide thickness of so minimum of the so from this what will be the maximum of these two 140 or 150 that we will provide. So the provide the thickness of wall 150 mm. What are the side walls? Okay, that thickness we are providing it as a 150 mm. So these are the two criteria which are used to calculate the thickness of the wall. Okay, thickness of the wall. So now we will calculate the hook tension. For that, the next step is this is your step number one. Then step number two is consider consider the bottom consider the bottom 1 meter height of wall. So from bottom 1 meter height of wall, we are going to consider. Okay, full stop. Pressure intensity pressure intensity corresponding to the pressure intensity corresponding to the center of bottom 1 meter height wall. Okay, so we have considered the wall, the height of the wall from bottom 1 meter height we have considered, and we have now calculating the pressure intensity at the middle of that 1 meter height. Okay, so at that wall. So pressure intensity we are now calculating, and that pressure intensity is the formula for the pressure intensity. This is the formula. So it is P is equal to W into H, so which is equal to 9810 into 2.5. आता हे 2.5 कुठून आलं तर बॉटमचे 1 meter हाईट घेतलेली आहे आपण 1 meter हाईट प्रेशर इंटेन्सिटी हियर सो दिस इज 0.5 okay but this is bottom 1 meter total height is how much total height is 3 meter depth of water तुम्हाला दिलेली आहे ना 3 meter so this is 2 meter so what will be this total distance total height if this total is 3 meter this is 0.5 then this is remaining is 2.5 meter so that is considered over here okay so 2.5 meter So which is multiplied by 2.5, then we will get the intensity 24525 Newton per meter square. Okay. So now from this we will calculate the hook tension. So hook tension, you have already learned the hook stress. Okay, while designing the chimneys in some also it is there, hook stress. So hook tension T is equal to, it is this rho d PD by 2. This is the formula. Okay, so it will be 24525 into height is diameter is 3.5. Here d is the diameter divided by 2. So it works out to be 42919 Newton. Okay, this is the hook tension. So we will calculate now steel required for 1 meter height. Okay, now this is the hook tension we got. Now we know the force. Okay, the simple basic formula is, you know, that force is equal to stress into area. Okay, now if I want to calculate the area, then I will divide this force by stress. So when I do this force divided by stress, I will get the area. This is the simple fundamental concept, so that we are going to use over here. Okay, so now what we will do, see, steel required. Now we know the tensile hook tension. Okay, we also know the stress. Steel required for 1 meter height is equal to, now we want to find out the area. So area is nothing but force divided by stress. So what is our force, what is our tension? 42919 divided by, what is the stress? It is 115. Okay, already this stress is given in the table, first table which I have given to you. In that table, look at that value 115. Okay, 115 is the value there we have considered. Okay, so now what we are going to do now, this is equal to, if we solve this, this works out to be 373.2 mm square. Okay, so minimum steel required in water tank. This is the MCQ question. Minimum steel required in water tank. It is 0.3% of gross area. Remember this. Minimum steel required for water tank, 0.3% of gross area. We always take it as. Okay. So minimum steel required is nothing but it is 0.3% of gross area. It is 0.3% of gross area. So it is zero point 0.3 divided by 100. Okay. So it is multiplied by 150 into, we have considered it is as for per meter 1. So it works out to be 450 mm square. Okay. So now after this, for 450 mm square area, providing 10 mm diameter bars. Okay. Now calculate the number of bars. Number of bars is equal to, it is 450 divided by 5 by 4 into 10 square, 5.72, which is nearly equal to 6 numbers. So AST provided, which is 6 bars we are going to provide, each bar of diameter 10. So this is equal to 471.23 mm square. This is our AST provided. Now calculate the spacing. So the spacing is S is equal to, how do we calculate the spacing? Area of single bar. This already we have studied so many times. Area of single bar divided by total area multiplied by width. That is per meter analysis is going on. If you solve this, it works out to be 166.66 mm, which we will round up it to 166 mm center to center. Okay. So बघा आता 10 mm चे बार आहेत. Okay. And what is the spacing? 160 mm center to center. But we need to provide the steel on the both the faces. Okay, which is away and which is towards the water. Go on both the faces, we need to provide the steel, and this same steel we are going to provide at the both the spaces. So if the same quantity of steel we need to provide on the both the spaces, then what we will do, 50% we will provide on one side, 50% on other side. So what we will do, generally we will double the spacing. If you double the spacing, then naturally the same steel will be provided on both the spaces. So this steel, write down this steel is is need to be provide at both faces, at both faces. Okay, so therefore steel at each face is equal to, therefore the steel at each face is equal to, it is 10 mm bar about 320 mm center to center. Okay, so we will provide on each face 10 mm about 320 mm center to center. Okay. So now what is the actual area of steel we have provided? Okay, if we provide now this steel on both the faces, okay, so therefore steel at each face. Now each face we need to provide this steel 10 mm bar about 320 mm center to center. हे काय आलं, दोन फेसेसला आलं. पण आपण काय कॅल्क्युलेट केलेलं आहे, टोटल स्टील किती आलेलं आहे, 160 mm हे स्पेसिंग आहे. टोटल स्टील तुम्हाला किती लागणार आहे, 10 mm चे बार लागणार आहेत, आणि ते 10 mm चे बार तुम्हाला किती स्पेसिंग वरती ठेवायचे आहेत, तर 160 mm सेंटर टू सेंटर स्पेसिंग वरती ठेवायचे आहेत. पण हे जर मी दोन बाजूला काय म्हणतात, दोन भिंतींना ह्या जर द्यायचं ठरवलं ही रिइन्फोर्समेंट, तर मला ही सेम रिइन्फोर्समेंट जर मी हाफ हाफ केली, तर मी एका ह्याला किती टाकणार आहे, 10 mm चे बार टाकणार आहेत, 320 mm सेंटर टू सेंटर. ओके, हे आपण आपल्या कन्व्हिनियन्ससाठी हाफ करतोय खाली, कारण आपल्याला दोन फेसला प्रोव्हाइड करायचंय. बट व्हॉट ऍक्च्युअली वी हॅव कॅल्क्युलेटेड, actually we have calculated that we are going to provide 10 mm diameter bars for 160 mm center to center spacing. Okay, so actually provided AST किती असणार आहे आपलं, actually provided AST, तर आपण काय करणार आहोत, तर pi by 4 into 10 square, okay, divided by spacing 160 into 1000. So this will give us the area. So what is the actual? It is 490.87 mm square. So this actual as it is we are going to provide. Okay. So this is the area of steel we are going to provide. So check for the tensile stress in concrete. This is next step. Check for tensile stress in concrete. So it is the tensile stress in concrete, it is calculated as tensile stress in concrete is equal to E divided by A plus M minus 1 into A. This is the formula. So T upon A plus M minus 1 into A. So now here we will put all the values. Here we will put all the values. Then what is our T hook tension? We have calculated 42919 divided by what is the area. Okay, so per meter, that is 1 meter we have considered, so it is 1000 mm into thickness is 150 plus m is the modular ratio. Okay, so the value of m, it is taken as 13.33 minus 1. Okay, this is the modular ratio in working stress method into AST, it is 490.87. These values all we have kept over here. So after solving this, we get tensile stress in concrete is equal to, it is 0.275 Newton per mm square. Newton per mm square. This is the tensile stress. So now vertical distribution of the steel. Now we will calculate the vertical distribution of the steel. So vertically also we need to provide the steel. So vertical distribution steel. Okay. This shall be, I will write here this, you can also write this shall be, this shall be at least 0.3% of gross area. Okay, so it is again zero point 0.3 divided by 100. I think this we have already calculated 150. Okay, into 1000. This is the our area. So it works out to be how much it is. If you calculated this 0.3 divided by 100 into 1000 into 150, this 450 mm square. This is 450 mm square. Okay, per meter. Again, this is per meter. So for this area, we will provide. We have already 10 mm distribution steel. Now we are providing bars about, so 10 bar about 300 center to center. And now the last thing is base slab. What is the base slab is there? For that base slab, now what we will do for the base slab means this will be 150 thickness with top and bottom mesh, top and bottom mesh of steel with with 10 diameter bars about 250 center to center. Okay, so this is the reinforcement what we have provided. Now we will draw the diagram for all this. Okay, so for drawing the diagram now, this is our vertical wall. This is the vertical wall of the water tank. Okay, this is the vertical wall, and at the bottom, whatever I am now drawing this is the base slab. Okay, this is the base slab. It is designed like this. Its depth is more towards this side. Okay, and join this, and here we will show section. Now we will provide the reinforcement inside this bar. So while providing the reinforcement, first on both the faces we have provided 10 bars above, 10 bars above, 320 center to center is there, and for base slab also we have provided 10 bars above, 250 center to center. So here this is the reinforcement which will be needed over here in this wall. Okay, so these are the bars which are anchored at top and bottom. आणि हे bars कोणते आहेत? तर these are the bars. I will give the name here only. So these are your 10 diameter bars, 10 diameter bars about 320 center to center on each face. आपलं 160 spacing आलं होतं, आपल्याला दोन फेस वरती प्रोव्हाइड करायचं. So it will become half. Okay, this also we can show 320 center to center. इथे आले हे बघा. Then vertical distribution steel also, here we can draw it. Here there is a distribution steel, vertical distribution steel which we have designed for the wall, that we will provide over here. I am slowly drawing this diagram so that you can correlate the steel. कुठलं steel कुठे गेलंय ते तुम्हाला लक्षात यायला पाहिजे. Okay, and the formula याच्यात जे वापरले by heart, those formulas are not there in the IS code. Those are the working stress method formulas. So you need to by heart those formulas. There is no any other alternative for that. So these are the bars, these bars which are, these are now 10 diameter bars about 300 center to center. Okay, 300 Okay, so it is 10 diameter bars above 300 center to center. This also we have calculated. Now after this, here at the base slab, the bars which are provided are in the base slab. Now at the top one bar is provided, at the top here one bar is provided which is anchored at the top itself, and at bottom again a bar is provided like this, which will bend and it will move in this way. Okay, and after this it will taken up to here. So now this bar, it is, we have already mentioned there. So I will again, these are the bars which are 10 diameter bars about 250 center to center. Okay. here now this bar is anchored like this. Okay, this bar is anchored like this, and also the distribution steel is provided. Here also the same distribution steel is provided. This is the distribution steel. Okay, and now we will give name to this. Again the same thing is there. These are the bars, 10 mm diameter bars, which are 300 mm center to center. So 10 mm diameter bars about 300 mm center to center. Okay, so draw this diagram, and here for your more information I'm telling you one thing here. With this joint, if you see this joint here, this joint, they says that it is a flexible base flexible joint, but in practice it is neither a very rigid joint nor a very flexible joint. Okay, sometimes bitumen is also used over here, okay, in this joint. So this is the typical section. This is the wall of the water tank, and this is the base slab of the water tank. So in this way, the water tank wall and base slab is designed. Okay. Now draw this diagram. So now with this we have covered almost all the things. Now the one more thing is there, that is from the next lecture onwards, I will give you the MCQs. Okay, MCQ test will be there. So MCQs will be very easy. You will find out the answer anywhere. In our design steps, you will find out the answer for the MCQs of every chapter. So we will take the MCQ test. So we are having 9 units, so at least 7 to 9 MCQ tests we will take from here onwards for every upcoming lecture, or I will drop all the tests at a once. Okay, I will make a Google form and I will give it to you for the test. So you have to solve it. Okay, you will automatically come to know the marks. In some tests there may be 5 MCQs each for 2 marks. In some tests there may be 10 MCQs each for 1 mark. And in some tests there will be 20 MCQs each for 1